gentlemen. So we are going to get started. So today what we're doing is we are going to go over that formative from yesterday. So you guys took your formative on naming. So we're going to go through that together. Have an idea of what we're looking for that summative on Friday, tomorrow. If you guys want to open up your formative on Canvas or you guys can just follow along. I'll post this video later so you can re-go through it in a minute. Class. Maybe. All right. So the first section, we were coming up with those chemical names. So we were writing out those we were given the chemical names to find the chemical formulas. So we have to identify ionic or covalent bonds before we can do that. So can you guys remind me, how would we identify if it's ionic or covalent? What are we looking for to determine if it's an ionic compound or a covalent compound?
Ionic has one metal and one nonmetal in it, and covalent has two nonmetals in it.
All right. So ionic has a metal and a nonmetal, and covalent has two nonmetals. Perfect. So now if we're looking at these, this first one, is this ionic or covalent? Is that two nonmetals or is that a metal and a nonmetal?
It's covalent.
It's covalent. What about the second one?
Ionic.
Ionic. Number 3?
Ionic.
Ionic again. Perfect. Number 4?
Ionic.
Ionic one more time. And then last but not least, this last one.
Covalent.
Covalent. Perfect. So we're going to go through, let's do both the covalent ones first, just because they're a little easier to come up with those chemical formulas, because we can just look at the name. How many sulfurs do I have for that first one right here? How many sulfurs do I have?
1.
1 sulfur. And that second element, what is that second element? What's the second element here?
Oxygen.
Oxygen. Perfect. We changed that ending to IDE, but it's really oxygen. And how many oxygens do I have?
2.
2, because of the prefix di. So SO2. And then let's go to that last one, the diphosphorus pentoxide, just because covalent is going to be a little easier for us to go through. What's that first element here?
Phosphorus.
Phosphorus. And how many of them do I have?
2.
2. So we're going to put a 2 there. And then the second element, what is it?
Oxygen.
Oxygen. And how many oxygens do I have?
5.
5. Perfect. So P2O5. All right. So now those ionic ones, we have to worry about those charges. So let's look back at tin. Do you guys remember what this Roman numeral stands for?
4.
It stands for 4, which means tin, so SN, has a +4 charge, or has 4 valence electrons it's willing to lose. What's our second element there?
Iodine.
Iodine. Perfect. And what's my charge, or how many valence electrons am I going to gain or lose with iodine?
1.
1, because it's going to gain 1 valence electron or have a -1 charge, because remember, iodine has 7 valence electrons and all of our elements want to have 8 valence electrons, which means it wants to gain 1 in order to have a total of 8 valence electrons to be stable, to be happy. All right. So now how many iodines do I need to have my total charge add up to 0?
4.
I need 4 iodines because I need 4 minus 1 charges. So I have 4 minus 1 charges and 1 positive 4 charge to give me my total charge equal to 0. So now if I was going to write this as a formula, what would my formula be? All right. How many tins did I need for this compound?
4.
I needed 4 tins.
Sorry. 1.
1 tin, and how many iodines?
4.
There we go. So it's SNI4. All right, let's look at the next one, magnesium. What is my charge on my magnesium? How many valence electrons am I gaining or losing?
One.
Careful, so remember to look at our periodic table. So if we look at that periodic table, let's find magnesium for me. What element number, what's the atomic number for magnesium? Where should I be looking?
2.
So it's here, so it's going to have 2 valence electrons instead of 1. So it's going to lose those 2 valence electrons, not just 1. So we're going to have a positive 2 because it loses 2 valence electrons. What's my second element here? What's my nonmetal?
Sulfur.
Sulfur. And how many valence electrons does it want to gain or lose?
1.
Let's look at our periodic table again. So double check. Find sulfur for me. What's the atomic number of sulfur?
16.
16. So how many valence electrons does it want to gain in order to have 8? Or how many valence electrons does sulfur have originally?
6.
It has 6. And how many does it want?
2 more.
It wants 2 more. So what's my charge on this sulfur?
-2.
-2 or -2 because it wants 2 more valence electrons to be full, to be happy. All right. So now what is my compound going to be? How many magnesiums do I need and how many sulfurs do I need?
One of each.
1 of each because our 2 charges, they add up to 0 already. We don't have to do any more. We don't need any more of either of them. So we have MgS. Then the last one, we have aluminum oxide. Aluminum oxide, aluminum is Al. And how many valence electrons does aluminum have? Anybody know?
3.
It has 3 valence electrons, so it's willing to lose those 3 for a positive 3 charge. What's my second element there?
Oxygen.
Oxygen. And how many valence electrons does it need to gain or lose to get to 8?
It has 6 and it wants to gain 2 more.
Perfect. So we have a -2 charge. Do our charges add up to 0? No. So which side do I need to add more to? Positives or negatives?
Negative.
All right. So if I add another negative, I add another -2 charge. Do they add up to 0 now? No. So which side do I have to change now? Is it still negatives or do I need to change the positive side?
Positive.
Positive side. All right. We're going to add another aluminum. Now they must add up to 0, right? All right. Which side am I changing?
Negative.
The negative side. Perfect. All right. They must add up to 0 now. They do. So now we have to write our formula. So how many aluminums did I have to use? 2. And how many oxygens did I have to use?
3.
3. Perfect. Any questions on that part? All right. So then we have our chemical formula. So writing out the chemical, going to chemical names now. So we have to identify ionic or covalent again. Which one is the first one ionic or is the first one covalent? CH4.
Covalent.
Covalent, perfect. What about the second one? N2O.
Covalent.
Covalent. What about the third one? ZnCl2.
Ionic.
Ionic. What about Ti3P4? Ionic or covalent?
Ionic.
Ionic. Titanium, Ti, is a metal. And then the last one, K2S.
Ionic.
Ionic. All right. So now when we're naming these covalent compounds, it's similar to when we did our formula writing, just in reverse. So we're going to take our two elements, we're writing those names down, and then we're adding those prefixes and changing our ending. So this first one, what is it? What element?
Carbon.
Carbon. The second one, what is it?
Hydrogen.
Hydrogen. Do we need a prefix in front of our carbon?
No.
No, because why?
Wait.
Why would we not need a prefix in front of that carbon?
There was only one carbon.
Because there's only one of them. So if there's only one for our nonmetals, for our covalent compounds, for the first element only, that's the only time we don't add a prefix. So carbon, all right. Do we need a prefix in front of hydrogen? Yes. What is that prefix?
Tetra.
Tetra, perfect. And then do we have to do anything else to hydrogen's name?
Add an IED at the
We're
end.
going to change the ending to IDE. So instead of hydrogen, it's hydride. All right, so let's look at the next one. What is our first element?
Nitrogen.
Nitrogen. What's our second element?
Oxygen.
Oxygen. Do we have to do anything or add a prefix in front of nitrogen?
Yes.
What prefix do we add in front?
Di.
All right. Do we need to add a prefix in front of oxygen?
No.
Careful, this one's the tricky one. The second element always gets a prefix no matter how many there are. We always have to tell how many that second element has. So what is the prefix in front of that second element for oxygen?
DE.
What is it?
IDE.
So that's the ending. Good. We changed the ending of oxygen to IDE. But what's my prefix going to be? Anybody remember the prefix for 1? Anybody? All right. Perfect. Mono. So we're going to add the MON. There's already an O, so we don't have to put 2 O's next to each other. So we have dinitrogen monoxide. Perfect. All right. We have ionic naming now. So with ionic naming, we always write our metal first. There's specific metals where we have to look somewhere in order to identify the charge. Which type of metals do we have to worry about that we have to add those Roman numerals for? Remember what that section is called?
Transition metals.
The transition metals. We have to worry about if there's Roman numerals. And then the non-metal, do we add a prefix to the non-metal's name? For ionic bonds, do we add prefixes?
No.
No. So we're just going to take that metal, which is Zn. What's the metal for Zn?
Copper.
Careful, copper. Cu. What is Zn? Zinc. Wonderful. Zinc. And then, is it a transition metal? Let's check. Is zinc a transition metal?
Yes.
Yes, it is. Let's see if it's on our ion sheet then. So let's look at our ion sheet. Do you see zinc on the ion sheet? Does it need Roman numerals?
No.
No, it does not need Roman numerals. So we are done with the metal. And then we just need to name that non-metal. What is that non-metal's name?
Chloride.
Chloride, because we changed the ending from chlorine to chloride. Perfect. All right, the next one. What is that metal's name?
Titanium.
Titanium. Check your transition metals. And if it's a transition metal, check your for Roman numerals and let me know. Does this titanium need Roman numerals? Is it a transition metal?
Yes.
It is a transition metal, so let's check our ion sheet. Is it on our ion sheet?
No.
It's not on our ion sheet, so we don't have to worry about it here. And so now we just have to worry about the non-metal. So what is our non-metal's name?
Phosphorus.
Phosphorus. And do I have to do anything to my phosphorus? Oops. Or am I done?
Do you add a tetra to it?
We don't add a tetra because it's ionic, so there's no prefixes, but there is something else we do have to change. Does anybody see what we have to change?
The IDE, or
We
change
gotta-
it to IDE?
We have to change that ending to IDE. Perfect. We got one more. We have K2S. What is that element K?
Potassium?
Potassium. Is potassium a transition metal?
No.
No, it's not a transition metal, so we don't even have to worry about Roman numerals. What does that S stand for?
Sulfur?
Sulfur. Do I have to do anything to my name for sulfur?
Change it to sulfide?
Change it to sulfide. Perfect. Any questions on naming? All right, so then if we go through these last 5 problems, we're going to go through these a little quicker just so I can give you some time to work on that review before your summative. If we look at that first one, CO was the question and they named it carbon monoxide, which is correct. And that's going to be correct because it's 2 nonmetals and because mono stands for 1, which means we have 1 oxygen and there's no prefix in front of carbon, which means there's 1 carbon. So 1 carbon and 1 oxygen makes that compound correct. The second one, the question was about cobalt-3 oxide. This one is going to be incorrect because that 3 tells us we have a cobalt with a +3 charge, or 3 valence electrons that cobalt is willing to lose. Oxygen always has the same charge at -2, or it's gaining 2 electrons, which means this does not create our compound because we would need 3 oxygens and 2 cobalts with a +3 charge in order to have our charges add up to 0. So it should have been CO2O3. The next one, potassium nitride, is also incorrect. And that's because the first issue is that P does not stand for potassium. What letter was potassium? What's our element symbol?
K.
Okay.
K. And potassium has that +1 charge because it's an alkali metal. And nitrogen has the -3 charge, which means we would need 3 potassiums to have our charges add up to 0. So it should be K3N, not PN3. The next one was super close to being correct, but it is also incorrect because of our endings. Remember, the first element, we just rewrite the name. It does not change its ending, so it should be sulfur. The second element gets its ending changed, so it should be hexa for 6, and then fluoride for fluorine. And then last but not least, this one down here, strontium and phosphorus. There were a couple issues with this one. The first one being strontium does not have a +3 charge, because if we have 3 strontiums and 2 phosphorus, we know the charge of phosphorus is always going to be a -3, which means there are 2 of them, which means we need 3 strontiums. And if our charges have to add up to 0, that means each strontium will get a +2 charge. So this Roman numeral wouldn't be correct. It's actually not correct either way. It never needs a Roman numeral, but especially because it says 3, in which strontium does not have a +3 charge. Then phosphorus needs its ending changed to IDE. Do you have any questions about your formative from yesterday? All right, then, ladies and gentlemen, you have a review on Canvas. Your review also has an answer key on Canvas. If you have any questions about your review, about naming ionic compounds, writing the formula for ionic compounds, drawing ionic or covalent compounds, naming covalent compounds, or formula writing for covalent compounds, please let me know. Otherwise, you guys have this review. It has drawing, it has naming, it has identification of ionic or covalent, and it has our wonderful formula writing at the end. If you have any questions, just let me know. I'm available today. I'm also available during your class time tomorrow. So if you have questions during the summative, don't just sit there and not take the test. Please come in and ask.